Hello and welcome to the fourth episode in the Peggle and PyGame tutorial series. Today we'll be creating a ball class. This will allow us to easily spawn, simulate and render the one or more balls that we're going to need for our Peggle clone. For this, and many future episodes, we'll be using the images that are supplied in the GitHub repo. All of these images I've laboriously modelled and rendered myself. It's taken me literally weeks on end to create and render these complex 3D models. This is done in free modelling software called Blender, and then subsequent touch-ups were done in Paint.net, like adding glow to the peg images, etc. Feel free to do whatever you want with these images. However, there are also sound and music files in the GitHub resources folder. These are taken directly from the Peggle soundtrack and game files, and I do not own these in any way. These assets are property of PopCap Games. You'll want to download the repo and grab the resources folder and drop it into your project like this. I'm also going to rename it to Res to shorten the file name a little bit. As per usual, I've forgotten to add some things to the last video, and to keep the tradition going, I'm going to make sure I forget something in this video as well. Remember folks, consistency is key. The things I forgot to add to the last video were a few non-essential functions you can call to set some basic extra information for the window that you create, i.e. a window caption or a window icon. I'm going to go ahead and quickly add these now. So let's set our caption. We're going to use the pygame.display.set_caption function, and it only takes one parameter, and this parameter is going to be a string, and it's going to be the name. So ours is going to be Peggle clone or Peggle tutorial or whatever you want to call it. And then we're going to use the pygame.display.set_icon function to set our icon, but we haven't loaded one yet, so let's do that. Just above this function call, we're going to create a variable called icon_image, and then we're going to use the pygame.display.load function with this file path to get the image that we need for our icon, or you can load any other one. If you wanted to make an icon yourself, it's best to have the icon be a 32 by 32 image, and then the background would need to be 2550255, which is kind of this pinkish colour, which I'm using as the colour key, basically meaning that any pixel with this colour will be considered transparent. Right, now we can just pass this image into our icon set function and we should be good to go. And as you can see, we've now got a little image in the top left and our title being displayed. Just adding this feature alone is going to get us probably about half the way to being a AAA title. And one other thing before we start, I'm going to remove all the temporary circle following stuff that we implemented last video, as it's, temporary, we don't really need it anymore, so we're going to get rid of all of that. Right, so with that out of the way, we can get into this video's content, our ball class. Despite its apparent simplicity, this class will need to store a fair amount of information. It needs to store a position, velocity, radius, diameter, image, bounding box, type, and a live boolean. We'll actually need more information in this class when we decide to add things like ball power-ups, trails, and long shots. But at the moment, this is all we're going to be implementing. The variable types we'll be expecting for these attributes are as follows. Position and velocity will both be 2D vectors. The radius and diameter will both be floats. The image will be a PyGame surface. The bounding box will be a PyGame rect. The type variable will be an enum, and as for the alive boolean, well, you're smart, I'm sure you can work out what type that will be. I'd like to note that we'll be storing the radius and diameter per ball, even though all the balls we're going to be spawning are going to be one size. The reasoning for this is that PyGame has a hard time scaling images, and it's just easier to store a single image sized nicely by an external program like Paint.net. PyGame scaling tends to produce weird looking artifacts around the edges of images that are scaled, that I just try and avoid at all costs. Although I didn't really have a choice when I was doing the extreme fever zoom, because that, it needs to zoom in real time. I thought about pre-scaling several image sizes in Paint.net and loading them in separately, but this seems like it would be more of a dirty implementation. So for now, the balls are going to be one size. I'm keeping the radius and diameter member variables just so that it will be easier to add variable ball sizes in future if we need to. And the memory overhead from doing this is basically negligible, so there's not really any downside, apart from the class is going to be like a tad more cluttered. Right, so let's start creating this class. We'll create a new file and call it, of course, ball.py. We'll need access to the vector class and its static functions here, so we'll import those things. We'll also want the enum class, as we're going to be creating a new enum in this file. I'm going to go ahead and create this enum right now. So let's call it ball type, obviously type enum. Then we're going to add one possible value and call it all caps default. And when we add things like ball power-ups, this is going to obviously grow in size. There's going to be more elements in this enum. Now we can start writing the actual class itself. We'll create a parameter list and assign default values to most of the parameters. The only essential parameter we'll need to construct a ball is its position. All of the other parameters can have default values set for them. When initializing our vector class with another vector, we need to make sure we call the copy function, otherwise we'll get a reference to the original vector, which can cause all sorts of weird problems, so we want to make a copy. We also probably want a place to store all the images that we're going to be loading in. So I'm going to create a new module and call it images.py. In this file, we're going to load the image of the ball and store it under the name ball default or something similar. Right, I'm just going to go through and add suggested types for each parameter in our class, and then we should be around about done. Right, okay, so the finished constructor should look something like this. One of the good things about PyCharm is now if we go and try and create a ball class instance, we can see all of these parameters have been listed nicely, and we can see all the types and which ones are defaulted and whatnot. Next, we'll move on to the ball's update function. At the moment, the only external information this function will need is the delta time and a gravity value. To get this info into the update function, we can either pass it as a parameter or include a module that statically stores it. I'm going to do the latter. I'm going to create a new module called commons.py and create the delta time and gravity variables in there. Because we're also going to need the screen surface in the draw function, I'll be moving that into the commons module as well. I'm just going to quickly update any uses of these variables to use the new module. Cool. Right, now we can start writing the update and draw functions for our ball class. The logic for updating the balls is going to be very similar to the demo we created last tutorial, except we're going to be just adding gravity instead of adding velocity in the direction of towards the mouse. So we're going to add the gravity constant multiplied by delta time to the y component of our velocity vector first, and then just add this velocity multiplied by delta time to our position. Right, and then we're just going to quickly create our draw function. So all we're going to have to do is just work out the position at the top left of our ball. So this is going to be the position minus radius in both components x and y. So I'm just going to quickly work out this top left position and store it in a vector, and then we can draw the image for our ball, and then the coordinates we pass in is just this vector, and we can call the makeInt tuple function. We're going to need a list of our entities somewhere, so again I'm going to be creating another module, and this one's going to be called entities.py. This module is just going to store lists of objects that can be instantiated, so like particles, balls, pegs, anything like that. And we're just going to create a list in here called balls. We're also going to add two manager functions that are going to update and draw these instances. These two functions are going to be very similar, except the update one is going to need to check the alive ball for each instance to see if it needs to be deleted, whereas the draw one is literally just going to call the draw function of each instance. If we want to remove instances while running through the loop, we'll need to do a reverse loop, so that we don't delete the element we're going to be moving on to next. To do a reverse loop like this, all we need to do is do a loop like we would do usually, so for I and range, but instead of just putting the len of whatever list, so in our case balls, we would need to do len minus 1, so we need to start on the second, well, the last element, and the second parameter in here is going to be the min, so min is going to be minus 1, we don't want it to go to minus 1 because it's not inclusive, and then the last parameter is the step, so it needs to be minus 1 because we're going down the list. And then it's as simple as saying if the ball at this location is dead, or not alive, then we just remove it. Simple. And now, in our main update function, the one in the main file, whatever you called it, we're going to call entities.updateBalls and draw balls in the draw function. Okay, and now for any balls inside that list, they should be updated and drawn correctly. However, we're not actually adding any yet. So let's add one when we click the mouse. In our event loop, we'll want to check for a new kind of event. This event will be the PyGame.mouseButtonDown event. We're going to make it only happen on the left button press as well. So we're going to check the event button variable, and we're going to check if it's equal to PyGame.button_left. And then if this is all true, then we're going to add another ball to our entities list. So entities.balls.append, and then a new ball type, and then the vector we're going to pass in is the position stored within the event. And running this now, we can see that whenever we click, balls will spawn and they'll fall to the bottom of the screen. Awesome. If we want to, we could spice it up a bit, and instead of passing a 0 vector for our velocity, or not passing anything, we could pass a random vector, and then multiply it by a large scalar so we can get some more random movement. It's worth noting that at the moment, when the ball goes off screen, it's still being updated and attempting to be drawn. This is not the kind of behaviour we want to see. What we want is the ball to bounce off the walls on the left and right and the top, and fall through the bottom, but when it's off screen, be deleted. So that's what we're going to do now. So to be able to do this, the update function needs to know the size of the screen that it's working with. I'm going to change the values we pass to the PyGame.display.setMode function as the window width and height to be two variables in the commons. I'm going to call these variables screen_w and screen_h, which is going to mean width and height. Then I'm going to create a new function in the ball class called checkScreenCollisions. So for the top left and right, we want it to collide when it is 1 radius away from the edge. So for the left, because the coordinate is 0 for the left, it needs to be if the ball's position in the x direction is less than or equal to its radius, then we need to bounce. And if its x position is greater than the width of the screen minus its radius, then we need to bounce in the other direction. And then the logic for bouncing on the top of the screen is the same as the left side, it's just with the y-axis. Then for the bottom, we need to know when it's passed fully off the other side of the screen. So we need to check when the position is greater than the height of the screen plus the radius. And if this happens, we're going to set the alive variable to false. And now you can see that that hasn't worked. It's because I'm being a complete idiot. You need to actually call the function we've created to see it work. Yep, there you go. Right. Now you can see it bounce. I've been an idiot 2 times in a row. Oh, I'm using the wrong kind of remove. That should be a pop. Okay, there we go. Okay, so if you're not a complete idiot like me, then that will work first time. Awesome. And just to make sure we're removing the balls correctly, I'm just going to print out this little statement here to show that we are deleting them. And then we can spam a bunch here. And there you go. You can see it's deleted them all. Awesome. So that's pretty much all we need for this ball class. And yeah, I hope you've enjoyed and you've followed along well. You haven't gotten lost by my awful explanations. And yeah, hope to see you next week. Yeah, next week, right? Definitely gonna happen. Introducing the Fergus Griggs Community Discord. Come on down and make a few friends, or enemies, or take part in one of our bustling discussion sections. Can't handle the heat? Well, cool off by taking a read through our rules and regulations. Or fill that hole in your soul with one of our 4 colourful roles. Just look at this satisfied member. So what are you waiting for? Join now. Link in the description. Cut. What a bloody waste of time, am I right? We are still recording, Joe, just let you know.